So we'll move further and look into few more basic concepts related to Verilog before starting off with the actual part. So I think we had discussed all these things, what is meant by abstraction, register transfer logic. Then we had discussed these things. We had done the comparison between HDL and Verilog and what were different levels of description or the abstraction. So in this we had discussed four types: circuit level, gate level, data flow, and behavioral. Circuit level is also called as switch level. Gate level is also called as structural level. And so we had discussed these things. Circuit level basically makes use of switches, and this is how the code appears. Then at the gate level, basic gates are the building blocks which will be used to build the model. Then so this is how the code will appear. And in data flow model, we make use of the equations or the expressions what is there in order to build the entire thing. Now here behavioral, it is the highest level of abstraction, and we had discussed that the possibilities at this levels are assignments, looping constructs, conditional, and one special this thing also we had discussed, that is concurrency, information related to concurrency. So this is one initial and always block, so which we'll be discussing again later as we move further with the Verilog discussion. So let us check out what is meant by concurrency and synthesis. Now what happens is you might have seen that when you're designing a circuit and rigging it up and providing it some say supply, for example, and you're applying some input to the gates, what happens is whenever you change the voltage level or the current level, all of those things get applied simultaneously. Say if I have say in an expression I have a variable which is named as a, that is the input, this thing which is named as a and b, and a is connected to say a multiple number of gates. So whenever I change it simultaneously, what happens is concurrently it gets applied to both. So here you can see just an example. So I have input A, to which you'll be providing say logic 0 or logic 1. So basically it will be a voltage, this thing what will be given, voltage or current depending on what is present. So here XOR gate is also having input A, and if you just see AND gate is also having input A. Now if you just see whenever A changes its value, that A will be concurrently applied to XOR gate and AND gate. So this is what concurrency implies. Now, whenever you're building a circuit, what happens is you're using a IC, and IC will be having some supply which is given. Similarly, there might be another IC which is also having the same stuff. Say if this is the XOR gate and this is the AND gate, and you are giving some 5 volt supply to it. Now what happens is when you're giving this 5 volt supply, if there is any change in this supply, it gets simultaneously applied to both the ICs. So that is indirectly to the gates which are present over here. So which will be later used for, because again the building blocks in this is nothing but again switches will be present. So these, that is in previous slides we had seen it. So here we had seen it. You are applying some supply and ground and other stuff. So here switches, this is a NOT gate. So what is happening is if any changes are happening, it gets applied to this. Suppose another inverter is there here, then if this voltage has changed, this will also simultaneously get applied to this switch over here. So that is what it implies. So simultaneously the inputs are getting applied over there. So that is, you can see that this concept generally comes in the electronic circuits. Say we have built some logical expression which gives some operation of the counter, and in that you have number of say gates you're using, and whenever you change anything, that time simultaneously it gets applied to where all that input is applied, so it gets changed. So that is happening in a concurrent fashion, that is parallelly it is getting applied. That is whatever variable a I was speaking in previous one is given to XOR and the other one was given to the AND gate. If some changes happen concurrently, it gets applied to this one and the AND gate. So that is what is specified by concurrency. Now that is what is given in next statement, that is the voltages and currents in the different elements in the circuit can change simultaneously, and this change has to be applied parallelly whenever wherever it is applied, that is it should occur in concurrent nature. Now in some cases what happens is you might require sequential execution, so under that you should take care of how that sequential this thing has to be done. So you'll be we'll be coming across all these concepts later, so even those things also come in. Now whenever we do this, in turn the logic levels too can change. What happens is, suppose if I have applied to the AND, I have applied variable a to the AND gate. So if this level changes, say if this was previously logic 1 and it becomes logic 0, then there will be some change which will be happening over here. And simultaneously, if you have applied it to the XOR gate, then there will be some change happening over here. So that is what this statement implies. That is, simultaneously A is applied to this, and simultaneously I may be getting a logical change which is present in that circuit. So that might happen over here. Now here, so simulation of such a circuit in HDL calls for concurrency operations. It is to cater to this hardware aspect what we are looking out for. So whenever we change some value, right, that is applied to AND gate and the XOR gate. So this should be happening simultaneously. That is, whenever change happens, A should be applied simultaneously. That is concurrency operation. So HDL has to incorporate that. So in previous slide, we had discussed that concurrency is one of the features which makes it different from the other programming languages like C program. So concurrency is one of the major features. That is parallelism you can specify. Now we have Verilog simulators that basically help us to achieve this concurrency operation. Now this is the difference between the programming languages which such as C, where what happens is in C programming the statements are executed sequentially. That is, if there is a statement 1, 2 and 3 and this is a C program, after first statement is executed, then only next statement gets executed. So if I represented it on a timing diagram, right, say for example first statement has been executed, so some operation has been performed in this time cycle. Next statement will be executed only once this is done, so next statement gets executed during its time period, so on it will continue. Whereas in suppose here I'm doing it like a is equal to b and some c is equal to b, so something of this kind. So here what happens is a's assignment will be done and here c's assignment will be done. Now but in Verilog, right, what happens is, or HDL, this might happen in a concurrent fashion because it is supporting the concurrency. Now both the assignment operators might start at same time, but if you want it in different time, you should take care of that and see where sequential execution is required. So here a equal to b is executed say at the 0th second. So at 0th second here what happens is c is also getting assigned. So if I don't want any ambiguity, then I should take care. If some dependency is there, then I should what I should do is I should check out that some sequential this thing has to be put in Verilog. So that is the difference between Verilog and programs such as C. So C is sequential in nature and Verilog is concurrent in nature. So that is what is specified. In some cases, we might require sequential operation. So in such cases, I should take care how that sequential operation has to be done and some major changes have to be done when you're doing the coding part. So since some sequential operations might be the data transfer what I spoke, A is equal to B, that is B is getting transferred to this, and after that C is getting transferred with some other value. If some dependencies are there, then those all things I should be taking care. Other examples are memory based operations, and so in such cases, what we should do is we should ensure that we should use proper constructs of the Verilog in order to implement the sequential execution demand. So this is the slight difference what we have to look out for. Now coming down to synthesis part, previously we had seen that we had simulation and analysis. So analysis we were doing, and then we were looking out for simulation. In synthesis what we do is once we get the analysis and simulation results, right, if some changes have to be done, we make those changes and again say rerun the entire thing and see whether it is operating in the proper form or not. Suppose I want to check out that voltage level tracking is happening or not. So if some changes are there, I design the entire circuit. Then I try to see whether it is tracking down the proper voltage or not. If it is not, then I try to change some parameters over there. Again, I rerun the entire thing. So once I do this, I'll be getting the final design description. Final design description. So it is once that is you're debugging the design. That is what you're doing. You're trying to establish. So here, once you get the proper design description right, you translate that design description into its corresponding hardware circuit, such as using a FPGA or an ASIC or even a CPLD. So this translation of the design description, which has been rectified or debugged and checked for its proper functionality, once you're translating it to the corresponding hardware circuit, we call this process as the synthesis. We call this process as the synthesis. That is translation of the debugged design into its corresponding hardware circuit gives rise to synthesis. So now coming back to Verilog's discussion regarding modules. So what is a module? Basically, it is a keyword, but by definition, we'll just look what exactly a module does. So any Verilog program basically begins with the keyword what we call as module. And previously also we had seen some examples. Now this is how we can just represent it. So don't worry what is happening over here. So we can see that there is a keyword which is representing this entire black box. So the module is like, as previously I mentioned, it is like the open braces or open parenthesis in C programming. It is like open parenthesis in the C programming. And if I have to end it, or we use the keyword end module, we use the keyword end module, which acts as a closed parenthesis, parenthesis. So Verilog program begins with the keyword what we call as module. So this is a keyword. Now module is basically it is a name given to any system which can be considered as a black box. I might not be knowing what the system is doing. So later when we are doing the coding and other stuff, that time we may get to know, okay, this is the operation what it is performing. So here module is the keyword which is used to identify the start of the Verilog program, and after this it is the name given to any system considering it as a black box. So this can be an adder, this can be a subtractor, it can be a multiplier, it can be divider, or it can just perform some logical operations. So it is just a name which tells that this is the entire system and it can perform some operation. It is a entire system and it can perform some operation. So what type of operation, this keyword is not telling. So therefore we term this as the black box. So I don't know what is exactly happening within. So it is just telling that this can be acting as an entire system, and so the name for this one we identify it as a module. Now again in this, what happens is we have three different types of ports. Ports are nothing but the terminals which are given to the module, which are the terminals which are given to the module. So in this, I can have an input port, I can have an output port, then I can have a bidirectional which is in-out port. So what is basically an input port? Input port is the port through which you can enter into the module. You can enter into the module. And output port is what? Output port is one through which one can exit the module. One can exit the module. And in-out port can is bidirectional. Is bidirectional. Using this port, you can enter the module and you can also leave the module. So that is what happens in this case. So this is just a black box representation what we are just observing here. So what is module? It is the name that is given to any system considering it as a black box which will have the input port and the output port or terminals as we specify. Now next thing to come down is what will a module basically comprise of? It has a number of lexical tokens. Like lexical implies the vocabulary, basically the vocabulary of the and here since we are speaking of Verilog, it specifies the vocabulary of the Verilog. So here that is what it specifies. Now here we have seven possible tokens. These all things you have come across. It is just a kind of recap, but the way we use it will be different. Now, the tokens are white spaces, comments, operators, numbers, strings, identifiers, keywords. So these are the seven possible, lexical tokens which are utilized in Verilog. So already you have come across these things. For example, white space. Enter is a white space which is identified by /n in C programming. Tab is a white space which is identified by /t. Therefore, similarly, we have different line return, form feed. So these all things. Then comments. So in C programming, if you have used comments, what you do is you write it as /* and */ anything which falls within this will be considered as a comment, and it is a non-executable part of the program. So similarly we have different types of operators, like logical operators, mathematical operators, then numbers, signed, unsigned. So there are again some other parameters also, then strings, identifiers. These are nothing but the name tags what we specify. In some cases, we call it as name tags. For example, in C programming, you might write it as int a. So a is the identifier, which is a variable of type int. So it is just identifying that parameter over there. And lastly, keywords. So basically, keywords are nothing but the names which have some specific meaning, and I cannot use it for any other purpose apart from what it is required for. For example, in C programming, int is a keyword, so which is used to declare variables of type integer. I cannot declare a variable with the name and int. So this is a syntax error. What we are doing, I cannot assign that. So we'll just have a look at a few of the things. Okay. So again, another definition of module will be a Verilog. In Verilog, if any program gives us the design description, then we call it as the module. Any program in Verilog which gives us the design description can be termed as a module. Any program that is written to test some design description. Now you might even write just the Verilog program to just see whether the intended operation is being performed. That is, you're just testing it. Say you might be testing the logic or some other aspect. So even that also we can call it as a module. Now when we are using it for test purpose, right? We are sometimes invariably we might use the term as testing module or stimulus module. So they are often sometimes called as stimulus modules or test modules or the test bench. So these are the terms which we can utilize. So here we can just observe a code which gives you just some how a module is defined, what is happening, so what all things are coming over there. So here we can see that module, this is the keyword which signifies that this is the start of the module. So it is just signifies the declaration of the module, or it also indicates that a module begins at this point. Now we have another keyword, end module. This specifies that this is the end of the module or the termination of the module. Now in between these, right, I can have several statements which might be arithmetic, logical, or any other operation, assignment operations. And if I want to end a statement, basically use a semicolon. So these all things. So semicolon indicates that it is end of the statement. Semicolon here also indicates that it is end of the statement. I can have a number of statements depending on what implementation you want to go ahead. Then we have a name which will be given to the test module. So module keyword tells that the module starts here, and what is the name of that module is given next. So test is the name of module in this case. So on it will continue in this fashion. So again, I'll just stress that this is like opening brace and this is like closing brace. So within this, all the things I can have. So this is how a typical structure of a simulation module in Verilog looks like. And previously also we had seen some examples. You can just compare with those. So now what are the constructs and conventions in Verilog? So constructs implies using what all things I can build a Verilog say logic, or I can implement a Verilog implementation, or can I obtain a design description. How I can obtain a design description using the Verilog, and what are the conventions we follow. Similar to C programming, it also follows its own, it has its own constructs, it has its own conventions, what you have to follow. For example, if I specify uh, that a variable in C program, it has to be, you cannot, in a variable you cannot use a keyword. So similar kind of things stands over here also. So let us see what are the constructs and the conventions over here. So first one, we can see that in previous slide also we discussed that we have 7 lexical tokens in which we have operators, keywords, identifiers, white spaces, comments, numbers, strings. So in this, is Verilog case sensitive? Yes, Verilog is case sensitive. So if you are declaring some parameter, say for example, if you are declaring a input as some variable in one, this in one, and later somewhere by mistake you might have used something in this form in one. So this is different from this variable, and this might give rise to some syntax error or some declaration error over here. Okay, so therefore you should check that. You should keep in mind that Verilog is also case sensitive because I is lowercase here, here it is uppercase. So Verilog is case sensitive. Next, what is meant by keywords? Keywords basically have some specific meanings and we cannot use it for any other purpose. For example, previously I mentioned int is a keyword in C programming. Similarly, here also we have some keywords. Few of the keywords what you came across was, say, the keyword module. Then these are the two keywords what you have come across, module and end module in Verilog. So these are the two keywords which are having some specific module, specific function. So module defines the start of a Verilog program, and end module defines the end of the Verilog program or termination. This signifies the starting point. This signifies the ending point. These are the keywords, and I cannot use these keywords. These keywords have some specific meaning and they have some specific activity which they have to perform. So for example, as I discussed, module, the keyword is module. It signifies the beginning of a module definition. Next, end module, which signifies the end of the module definition. So similarly, we have begin, end, that is for begin and end So beginning of a block and a ending of a block. Then we have if, while. So these are all different aspects which are present. So while is a looping construct, if is a conditional construct. So that is what we can look out for. So these are the keywords. So as we go ahead, right, we'll be learning new keywords around and how we can use them in a Verilog code. So that is what we can check out. So next, what is meant by identifier? Identifier is nothing but a name tag which is used to identify a parameter. So generally, again, I'll just compare it with the C program. So if you just see, we write it as int. Say I'll write it as num1 and some variable name as temp, something as in this one. So here num1 and temp are integer, are variables of type integer. So here num1 and temp will be the identifiers. Num1 and temp are the identifiers, and this is the name tag what we are giving for that purpose. This is the name tag. So any program basically requires such kind of name tags in order to build the entire code itself. So identifiers are nothing but the attached name tags, which will be used to identify the statement signals and other stuffs. Okay. Now these name tags itself are the identifiers. Name tags, for example, it can be clock, enable, gate one. Uh, so these are just few examples. So clock is the name tag or the identifier, enable is a name tag or the identifier, gate underscore one is a name tag or a identifier. So these are nothing but the variables what we speak in C programming. So such kind of elements. What type is there, that we have to see, whether clock is input, enable is input, whether this is output, whether anything else is there as in out, whether anything is present as wire. So these are the different things what come under the name tags. So what are the restrictions when we want to assign some name tags, or when we want to assign some name tags to the identifiers? So there are some restrictions in Verilog. So the first one is what should be the first character? What character is permitted? All the characters in the alphabets can be the first character, or an underscore also can be a first character. So if I want to say rename this, I can rename it as underscore gate one. So underscore is permitted. Clock, if you just observe, it is having all the alphabet in its name tag. So this is also permitted. I can write the same thing as uppercase C and rest all lowercase. This is also permitted. Remember that it is case sensitive. So whenever you're using those things in the later this thing, see what you have used and then use it. So generally you try to follow one convention itself. Either you go for camel casing or say title casing, or you use the underscores. Suppose you have some here how we have first gate is identified by gate underscore one, or you can just replace it as ONE gate underscore TWO. So you follow some convention over there. So first character can be all alphabets, or it can be a underscore. And what can be the next characters, that is subsequent characters? The subsequent characters can be alphanumeric type. It can be followed with numbers or alphabets, and it can be followed with underscore. Underscore, here you can just see an example of this, wherein underscore is present in between. Or you can have a dollar sign. So this is one special this thing which you can use. So you can use a dollar sign. So suppose I can write it as C dollar. So this acts as a variable. So clock underscore dollar. So even this is also permitted. So these are just a few things which you can utilize. Those are related to white spaces, those were previous discussion were related to the identifiers and the keywords. Now next one, what we'll see is what is meant by white space. So white space, when you're speaking regarding this, so whenever you are writing some lines of codes, say I write it something as int integer one, something I write it in this form, then I write something as float f1. So what I'll do is here you can see that in the next here I have declared some variables. Now what I'll do is I might leave generally coders follow this kind of thing so that you can read the code in a much better fashion. So what I'll do is I'll leave some space over here. Then I might do some operation wherein f1 is equal to something like this, int 1. I might do this operation, and after this, so here what I have done is I have done some assignments over here. Here I have declared the variables. I have done some assignment over here, and after this I'll leave one or two lines, and then if say for example f1 is greater equal to some condition, I'll be executing some statements. So here you can see that here in this part I am declaring it. In this part declaration is happening. So in this part declaration is happening. Here say assignment is happening. Here some conditional operations are being performed. So what you're doing is you're using say slash n, that is enter. You're pressing enter over here, so which is similar like slash n. So this is a white space what you're introducing. So what this does is this improves the readability. That improves the readability. Now if you mix everything, what happens is I have to check out where what is there. Suppose I declare int I1 here, then I do some I1 is equal to 10. Then I write if I1 is greater equal to 0, then perform some operation. Then what I'll do again, I'll write I want some other variable f1, then f1 is equal to some I1 I'll do. So what is happening here also you are declaring, here also you are declaring. So what happens is if many variables or parameters are present, then keeping track of these becomes difficult. So keeping track, if you want to make some changes, right? Sorry, here, if you want to make some changes, then you have to keep track where all the integers, where all these variables are declared. So what I do is basically declaration is given in one part, then rest all operation is done in the other part, so that you can do debugging easily. So basically again indirectly what you're doing is you are improving the readability also, and you are improving how you can debug further. So some syntax errors there, I can debug it in easy form. So what are different white spaces? So blanks, tabs, then new lines, form feeds, then comments. Now comments are basically used to improve the code readability. Code readability in the sense, now as I specified previously, I had something as int I1 and float F1. So here I have just declared I1 and F1. Now if I want to improve the overall code readability, if I put some comment over here, so something using this case. So I1 I just specify something as reads temperature, something in this form. This one does some other operation. This one reads say some other sensor value. So if I put these comments right, if I put these comments, then what happens is I'll be able to understand the code in a much better way. That is what comments help us to do. It improves the overall code readability. Now if I want to comment a single line in Verilog, what I do is I make use of double front slash and then put the statement. So this is just an example what we have, what I'm showing. So double front slash, whatever comment you want to put over here, double front slash again whatever comment you want to put over here. So this will comment only the single statement. Now if you press enter, if you go to the next line won't be under the comment line. So if I want to comment a block of statements, then I make use of this method. So wherein I am commenting statement 1 and statement 2 all together. So in order to do that, I have to make use of this operator, that is front slash star, or put whatever statements you want to put under comment, and lastly you can to end the commenting, right, you have to put star and front slash. So this is what you will be doing in this case. So this is with respect to commenting. So lastly, we'll just check what are the different operators which come in. So again, in a later stage also we'll be discussing all these things. So this is just an overview of those parameters what we will be discussing later. So operators, I think you have come across even what is meant by unary operators. So unary operators basically operate on a single operand. Unary operators are basically operate on single operand. So you have unary operators in Verilog. For example, A is equal to negation of B. So negation is a unary operator. This tilde, this thing what you can see, right? So this is a negation operator. So binary operators are nothing but which operate on two operands. For example, A plus B plus is a binary operator. So here you can see that this plus is a binary operator which is operating on B and C operands. Then we have ternary operators which makes use of three operators to decide on some factor. Now this one you might have seen in C programming. So similar kind of ternary operator is present in Verilog. So if you just observe here, what should be the value of B? It depends on B, C and D. So depending on what is the value of B, it either assigns C or it assigns B. So using three operators, you are using three operands, you are deciding what value has to be assigned to A. If B is true, assign C. If B is false, assign D. So something of this kind. This is how it is read. So this is a ternary operator. So any query?